Okay, good evening. My name is Hemant Kumar. I am from Ericsson. I am a solution architect. In this talk, we will be discussing about the Tempest plugin and how to use the Docker or the container to launch the Tempest plugin and how to test our Openstack services. So, as we all know, Tempest is the integration OpenStack project where it provides a test framework as well as the test cases to verify your OpenStack API testing, scenario testing, and CLI testing. So on the right side, if you see there are the Tempest test cases, several boxes. Let's say you have very specific test cases which you want to develop for your own cloud, everything some specific. So how do you do that? You can't write a separate framework again. So what Tempest provides you is a plugin kind of framework. So Tempest provides you a plugin interface. Basically, you can create a new repository and then write this, inherit the class and override these methods. So thinking from the Tempest and Tempest plugin point of view, what Tempest requires basically is from the plugin, it has to know where are all the test cases are located within the plugin. So the first method load_test provides that. So the plugin should implement that method and provide where the test cases are located. And then you might have use cases where you want to incorporate some new options or the configurations for your plugin. So how do Tempest know about all those options? So you have to implement the register ops and specify those options. So Tempest will read from the Tempest configuration file and provide these options values back to the plugin. And then we have get ops list to get all the options. And also we have something called service clients. Typically for any Nova or any common OpenStack projects, you will have the service clients already in the Tempest. But if you want anything new, you can still develop your service clients within your plugin and you can use them. So how Tempest knows basically where are all your plugins are. If you see all the Python packages are installed, so how it actually identifies which is the Tempest plugin package. So Tempest relies on the setup tools entry points to auto discover all the Tempest plugins. So in your entry points, you should specify the class of your plugins. So why we are discussing about the Tempest plugins basically is if you see from the sprint cycle onwards, we are moving towards Tempest plugin for every OpenStack project. What does that mean? If you have a project called Keystone, you will see a new project called Keystone Tempest plugin where the project specific API test cases will be in that project. So Nova, you should see the corresponding Tempest test plugin. So you are going to see a lot of plugins in future. So these are the Tempest plugins that are available today. So you can see Keystone, Murano, Neutron, Freezer, some plugins. But still we need to develop for Nova, Neutron, so many projects, Glance, Cinder. That's why we are discussing how to write this Tempest plugin. So basically we contributed to the Cinder Tempest plugin. We did it from, we submitted the code and waiting for the review process. So that it makes easier for the developers just to write Tempest test cases on the top of that plugin. So now you can see here 10 to 15 plugins. Now you might have in 3 months time or 6 months time, you will have 20 to 30 plugins. So I am interested in testing only only 4 or 5 main plugins or the main projects. So how do you go about that? We have mix of combinations of the plugins which you want to test it. So what we are proposing here is a REST-based service to test your Tempest test cases with combination of plugins. So give us your plugins which you want to test it. Give us your cloud credentials. We will test it for you. Otherwise, we can also launch a DevStack cloud or a small cloud inside, and we can test your Tempest test cases. And we will return back the test results as well as the logs. So we are leveraging the container technology internally just to create multiple Tempest environments based on the user requests. We are also in sync with the Tempest design principle. Basically, what Tempest tells is, irrespective of your cloud, OpenStack cloud, whether it is a DevStack cloud, whether it is a full-blown production cloud, your Tempest test cases should be same. Tempest should be same. No tweaks are allowed. If anything you want to change the configuration. So we follow the same basic principle here. this is how the architecture we are looking forward. So on the left side, you have two components, API server as well as engine. On the right side, we have a Kubernetes cluster, Kubernetes controller and K8s node minion. So these are the two new components, API server and the engine. So the user will request with the combination of plugins which he wants to test, as well as the cloud credentials. And the information is validated within the API server, and it requests the engine to run the test. So engine do a lot of steps. So the first thing is build your Tempest image. So for this process, it is not just the Tempest project. Now we have plugins which we don't know which plugins, because the input is coming from the user. So we can't have a predefined images. So we have taken some Docker image references from the Cola project, and we have extended it to install the Tempest plugins as well dynamically. So that is the first part we do, and we push the image into a local registry. And then second part is the generation of the Tempest configuration. Typically, most of the configuration parameters will be default. Some parameters we will try to take it from the Openstack cloud itself by querying the Openstack cloud, whether, for example, some services are up or not. If something is down, we can take that information from the Openstack cloud and we can update the Tempest configuration. Of course, some parameters will come from the user request itself. There are some more steps that might be required, like certificates, SSL certificates, which are not shown in this picture. Once you have the Docker image and once you have the Tempest configuration, the next step is create your Kubernetes deployment file, Tempest deployment file. So we dynamically create that file, and then we trigger a API call towards the Kubernetes cluster. So the Kubernetes cluster will bring up that container and run all the Tempest test cases, and it generates the Tempest logs. Once the logs are generated, the engine will capture the logs, pull out the logs, and generate the necessary reports and give it back to the users. So this is how the general architecture which we are thinking about. So in this diagram, we just mentioned Rocket just to say that if Kubernetes supports, we can expand it or extend it. So what's our next steps? Our next steps are basically creation of the Kubernetes deployment file. It may not be standard, so we want to use some standardized method. So we want to develop an OpenStack Helm chart for the Tempest container instead of K8s YAML files. That is one. And the second one is, until now I am talking about only plugin container plugins. I didn't talk about the patch sets. Let's say I have developed and I have a patch set. I want to get that patch set really tested. So I can give that patch set IDs also as an input, and they will be tested. Or it can be your local GitHub as well. It may not be patch set onto the review.openstack.org. It will be tested. So another couple of possibilities which we are exploring more is, do we really require the cloud credentials from the user? How we really take it? We are contemplating to use the access delegation. Keystone today supports the OAuth API. So can we use those API and do access delegation and use those tokens to test the Tempest test cases? This is what we want to try more on this. And the last point is on the Tempest concurrency. If you see in the Tempest can run test cases in parallel based on the concurrency settings, and of course you should have the number of cores on your server. So there is nothing wrong with the architecture which I have shown earlier, because Docker or the Kubernetes, it can see all the cores on your server. Even it's a single container, it can see all the cores and it can run the test cases in parallel. But our thought process is like, is it really a microservice architecture, or do we want to go into a microservice architecture for Tempest? That's how our thought process is going on. And yeah, we are not come up with an idea, so we are still thinking on that part. So this concludes my talk. Thank you.